Hello, in this video, we're going to be looking at the second half of lesson 7.3 on triangle similarity. If you haven't already taken the notes for 7.3 day 1, you should go back and watch that video first. Today, we'll continue with our essential question, how do you prove that triangles are similar? In the previous video, for the first half of this lesson, we talked about 3 different ways that you can show that triangles are similar. The first way is called the angle-angle similarity postulate, and we abbreviate it as AA similarity. And that tells us that if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. The second way that we can show that triangles are similar is the side-angle-side similarity theorem. And this tells us that if an angle of one triangle is congruent to an angle of another triangle, and the 2 sides that include the 2 angles are proportional, then the triangles are similar. The angle that you have that's congruent must be right in between the 2 proportional sides in order to use SAS. Finally, we have the side-side-side similarity theorem. And this theorem tells us that if the corresponding sides of 2 triangles are proportional, then the triangles are similar. And here, remember that we need all 3 sides to be proportional, meaning they're all in that exact same ratio. Moving on to example 2, we're now ready to find some lengths in similar triangles. And we are going to first show that the triangles are similar using one of the 3 similarity postulates theorems that we just discussed. And then after we've shown that the triangles are similar, then we can go and find the length of a missing side. So in this problem, let's first just read the similarity statement. We want to explain why triangle RSV, which is the smaller triangle here that I'm outlining in red, why is that similar to triangle RTU? And triangle RTU is this big outermost triangle. When the triangles overlap like this, it's going to be easiest if we draw them separately. So just kind of here below the picture, I'm going to draw the red triangle, and your drawing doesn't have to be perfect. You just need to make sure that you have the markings right and the numbers right. So this is RSV, and then we have a 10 here and an 8 there, and the angle. And then I'm going to make the green one, the bigger one, and that is RTU. And then we have angle T with the mark there, and then 12. And we actually don't know the length of this side. This is like side RT. That's what we're trying to find. So I'm going to put an X right there. But before I find the X, I need to show that these triangles are similar. If they're similar, then we can solve it with a proportion. Now, you'll notice right now that we only have one angle, and we don't have enough information to use SAS because I'm missing this value right here. But what you can notice right here is that since these triangles are overlapping, they actually share an angle right here. So this is a shared angle. Both angles, or both triangles, have angle R in them. So let's mark angle R and angle R. Well, now I have enough information without any of those side markings to say that they're similar by angle-angle similarity. Let's make this a little bit more formal here. So I'm going to just list them out. So angle R is congruent to angle R by the reflexive property. Of congruence. And then angle S is congruent to angle T. And I'm going to get, I guess, a little bit more specific because in my picture here, angle S, there's a couple different angles there. So let's do 3 letters. Let's go angle RSV. is congruent to angle RTU. And that is given. That was marked in the original diagram. So now we can say that, therefore, triangle RSV is similar to triangle RTU by angle similarity. So that just established why they're similar. Okay, I did kind of a bullet pointed list here. So that's my angle, that's my second angle, and that's my y. Angle similarity. Now, to finish off the problem, we need to find the length of RT. And since I drew the pictures separate, it'll be kind of easy to see what matches. You can also actually just use the statement. So, for example, RS, see how RS is the first two letters? Well, RS has to match with RT in the other triangle. And then another match would be SV here, which is 8. Well, SV matches with TU, which is 12. So I'm going kind of from left to right. So putting the numbers in, that would be 10 over x equals 8 over 12. And now we can just go ahead and solve that with our cross products. 10 times 12 equals x times 8. 120 equals 8x. And then if we divide by 8, we get 15. So the length of RT must be 15. Let's try another example. This time we have two parallel lines, and anytime you see parallel lines, you should be thinking about angle pairs. So there's a couple of different ways that I can get angles. I guess the first way that I'm going to notice here is that I have parallel lines and I have a transversal. I actually have two transversals. So you can pick which transversal that you want to look at. I guess I'm just going to pick this one that I outlined in blue. And if those are my parallel lines in my transversal, angle C and angle E are alternate interior angles. And then another angle that I can get is these two angles right there are vertical angles. So the plan of action is going to be to show that these triangles are similar by angle similarity again. Let's just write that out. So I'm going to start by listing that we have parallel sides, because if I didn't have these parallel sides here, I wouldn't be able to get that pair of alternate interior angles. So we'll say that AC is parallel to DE. And again, I'm kind of just using the similarity statement to match up my things. AC matches with DE. So angle C is congruent to angle E by alternate interior angles theorem. Then we can state the vertical angles, and the vertical angles are the ones that I marked with B. So I'm going to say angle ABC is congruent to angle DBE by, and it's the vertical angles theorem. And then, therefore, triangle ABC is similar to triangle DBE by angle similarity. So there we've established that we have similar triangles, and now we can go ahead and find that missing measure that it asks us to find. We want to find BE, so I'm just going to put a little x by BE, and then when we're writing our proportion, we want to be super careful. So for example, AB, which is the 36, AB has to match with DB because they're in the same spot in the statement. And then CB, or BC right here, BC matches with BE. If I put my numbers in there, it would be, so AB is 36, DB is 54, BC is also 54, and then BE is the side we want to find. Well, now we have a proportion, and we can solve it with cross products. 36 times x equals 54 times 54. So that is 36x equals 2,916. Grab your calculator and divide by 36, and we get 81. So the missing side, side BE, is 81. Now that we've gone over how to explain triangles are similar, I want to just show you an example of how you could make it a little bit more formal by writing it in the form of a two-column proof. You're not going to have to write formal two-column proofs on your unit test, but I think it's good to see one example in the notes, and you're going to see that it's pretty much just the same as what we did, except we have to start by listing the given. So notice that in this problem, it's given that line MN is parallel to segment KL. So that is given. And then let's mark that in the diagram with the arrow markings. Since we have parallel lines, we can then get a variety of different angles. And I'm going to just use kind of this transversal right here in purple. Well, if I look at that transversal and the two parallel lines, this angle right here, angle JMN in the smaller triangle, so angle JMN is congruent to angle JKL, and those are just corresponding angles. So corresponding angles postulate. All right, then I could get another pair of angles using corresponding if I wanted to, or because the two triangles are sharing angle J, we could just use that. So I'm going to use angle J is congruent to angle J by the reflexive property of congruence. And now we have enough information there. We have two angles. Notice that in the smaller triangle, we have angle J and angle M. And in the larger triangle, JKL, we also have angle J up here and angle K down there. So that is enough information to complete our proof. So we have enough information now to end the proof with, for final line right here, to say that triangle JMN is similar to triangle JKL, and that is by angle-angle similarity. If you like the two-column format better than kind of the bullet point formula that I used in the video or the writing short sentences like I used in the video, you're welcome to explain your answers this way, but it's certainly not a requirement. Finally, before we end this video, here's just a couple quick things to remember. Reflexive property of congruence is going to be very helpful, particularly if you have a shared or common angle. So when your triangles are overlapping and they both have a corner in common, that's a common angle, and an angle is congruent to itself using the reflexive property. Also, anytime you're given that two lines are parallel, watch out for angle pairs like corresponding angles. In my diagram here, angle 1 and angle 2 are corresponding angles from parallel lines in a transversal, so they're congruent by the corresponding angles postulate. Also, angle 3 is congruent to angle 4 by alternate interior angles theorem. This concludes lesson 7.3. Thanks for watching, and good luck as you practice some problems on your own. Bye.